In this experiment, we will be measuring the thermal conductivity of several different metals. Thermal conductivity describes the transfer of internal energy by diffusion and collisions of particles within a material. As heat is applied to the material, the particles that make up the object begin to speed up or slow down, bumping into each other along the way. The heat is caused by the kinetic motion of the particles as they bounce against one another. In today's experiment, we will examine the rate of conductivity in 5 different metals as we insert them into cold water. Instead of inducing a hot temperature in which the particles of the metal begin to speed up and bounce off of each other, the cold temperature induced will cause the opposite. As the particles slow down, they no longer bounce off of each other, causing their neighbors to begin slowing as well. 2 of the metals, copper and aluminum, are pure metals. 3, stainless steel, and red brass are all alloys of a pure metal. For this experiment, the prediction is that the pure metals will conduct heat, or in this case the subtraction of heat, faster than alloys because the different composition of atoms in alloys will cause them to stop bouncing off of each other and slow down at a rate slower than the atoms of pure metals. After all measuring a starting temperature of 79 to 79.5 degrees Fahrenheit, the metal tubes are placed in ice-cold water and measured at 3 inches from their base. To measure the rate of decrease in temperature, I take measurements with a temperature gun at 1 minute after their submersion, 3 minutes, 5 minutes, and a final measurement of 10 minutes. Here's how the metals varied in temperature. Overall, copper and aluminum lost the greatest range in temperature. After calculating the rate in temperature change per minute, we can see a small but obvious separation. Pure metals lost temperature at a faster rate. These results seem to confirm the hypothesis that pure metals will be more conductive than alloys.